Fine, yes, let's start. So in previous session, we have seen a basic introduction of ML. Okay, so we understood ML is a pattern matching system. Fine. And we have seen what are the reasons for the recent advancement in machine learning or data science. Okay. And we have seen where all we can use ML. Now, in today's session, we are going to see few different types of ML. Okay, so over here, okay, so fundamentally there are four different types of machine learning. Okay, so first thing is first or just give me a second, guys. Let me pick it up from what I can do. Hmm. Okay, so over here, as you can see, fundamentally there are four different types of machine learning, guys. Okay, one is supervised, one is unsupervised, one is semi-supervised, okay, and the one is reinforcement learning, the last one. Fine. So over here, what happens in supervised is, so as I said, what is machine learning? Okay, so what is machine learning fundamentally? It will learn the pattern, okay, based upon certain training. Fine. So the simple definition of machine learning. Okay, so over here, first of all, for it to learn the pattern, so we need to pass it both input, okay, and also output. Okay, once it is trained, then we are going to pass the only input, test input, so that it is going to give some predictions. Okay, so the branch of machine learning in which, okay, in which we pass both input and output. Fine, we pass both input and output to the machine learning is called as supervised machine learning. Okay, it's called as supervised machine learning. Fine, that means what? First we'll pass input, along with that we'll also pass output. It's okay. From that input and output combination, we'll try to understand some pattern. Okay, once we are confident that the model got trained enough, fine, we are going to send some test data. On that test data, it is going to do some predictions. Okay, but the main point is we are going to pass both input and output for the training. Getting this?
Yeah, Santosh.
Okay, so now coming to unsupervised over here, okay, over here, we don't pass both input and output, okay, because there is no output variable over here. Okay, so fundamentally, any machine, usually the data set of ML looks like you have different columns. Okay, so here it will be C1, C2, etc. Let's say C10. Okay, 10 inputs, and there will be one output. Okay, all these are okay. Let me call it as X1, X2. Okay. Yeah, this is fine. Right. So all these are called as inputs. Okay, or they're also called as attributes, or they're called as feature. features or feature variable. Okay, so this feature is the most famous term. Fine, you can also simply say input or attributes or features. Okay, but features is the most famous term. Now this y is called y, which is output, right, which is output, is also called as target. Okay, so feature and target are the two famous terms which are used to refer input and output. Fine. So from now on, I will also call them as feature and target. When I say features, you should understand that these are input columns. Okay, the input to the model. Okay, and when I say y, so when I say target, so that is the output variable. Fine, features and target. Remember this. Now, stepping one step back. So in supervised, we will have both features, okay, and also target, guys. Okay, so we will pass both of them. Okay, system or the model algorithm understands some pattern. Based upon that, it is going to give some predictions. Okay, that's a high level definition of supervised machine learning. Okay, we will see in depth what is that and what are further categories in supervised, but this is a high level. Coming to unsupervised, okay, coming to unsupervised here. Okay, here, oh, okay, so yeah, so as you can see, there are a few examples of supervised. Okay, so you have house price prediction or medical imaging. Okay, or most of the ML. Okay, what usually which we work upon, okay, is from the supervised learning. Okay, so as we have seen in the first session, so spam classification. Okay, so spam classification or diabetes prediction or heart attack prediction. Okay, or related to stock market prediction. Okay, so most of the real life examples where we predict something. Fine, so where we are predicting something. Okay, those comes under supervised. Why? Because the moment when I say we are predicting something, so obviously it means that we have already trained it. Okay, before training we cannot do any predictions. Okay, because without understanding the relationship between input and output, no one can predict the new values. Fine, so all this, so we can have tons of examples. Okay, in any domain you take. Okay, for example, in insurance, if you in banking sector, if you speak about, you can say whether if a loan can be given to this person or not. Okay, I want to predict that. Okay, whether this person payback rate is good or not. Fine, so or in agriculture section, if you want to see whether this particular tree, okay, the leaves are rotten or not, or in the iris section we have seen whether this is an only prediction done in SL, not the types of ML. Yes, Sirisha, we are coming to that. We are coming to that. Okay, so fine. In medical domain, if you see diabetes prediction or heart price prediction, fine. Or the other simple example like house price prediction or in spam detection, fine. So all these are examples of supervised machine learning. Okay, supervised learning. Fine. Is it clear, guys?
Yes.
Okay. Now that is regarding supervised. Now coming to unsupervised. Okay, coming to unsupervised. Here what happens means, here you will have only features, guys. Okay, here you will have only features. Fine. So because what happens over in supervised machine learning is, why we don't have target variable. Okay, in unsupervised learning, so I said we have only features. Okay, that means we don't have this target variable. Okay, why we don't have a target variable, let's understand that first. Okay, because now again going back to supervised, when I say this, when I say for example, let's take a simple spam detection. Okay, so I'm saying in supervised learning, okay, in supervised machine learning, okay, what do we have? We have both features, okay, but plus target. Okay, fine. So now what is the features, guys? The input, okay, how the email, okay, what are the most repeating words in an email? Okay, fine. So what is the pattern of the email? That is the features. Fine. So that means how many congratulations words are there or how many discounts words are there. Okay, so etc are my features. Agree? These are my features. Now, what is my output? What is my output variable? My output variable is whether this is spam or not spam. Okay, spam or not spam. Agree? Now the point here is who is going to create me this output variable? This you are going to get it directly from the email or the input, whatever you are receiving. Like for example, this is mail one. Okay, M1 mail one. Okay, you got a mail one. So in that there are two congratulations words and zero discount words, etc. You can have this data set. Okay, because that is directly coming from your input, whatever the mail you are receiving on your inbox. But the corresponding mail or not mail, spam or not spam, fine. So who is going to decide that and create that variable for you? Fine. You need to do that, right? So that involves a lot of manual work. Once you do that, okay, then your data set is ready along with both features and target variable. Then you can use it for supervised machine learning, okay, or some classification purpose. Right, but without this output variable, it is not possible to proceed for any model training. Okay, training cannot happen without input and output. Do you agree, guys?
Yes, sir.
Right, so obviously you should have both input and output, but the input obviously you are going to get it, okay, whether let's say you are working in a bank and you need to do certain, okay, a small prediction, like whether a loan can be given to this person or not. Okay, like that, let's say you have 1000, okay, simple 1K customers data, and what is this credit card amount, okay, limit, and what is this usual money withdrawal, okay, money withdrawal amount, and money deposit amount, okay, what is his salary, etc, etc. You are going to have all these inputs, okay, all these features. Okay, this is for person 1, person 2, okay, let's say till person 1000, you are having these details. Okay, these details are readily available in your system because you are a bank employee. You can have access to all these financial details. That's fine. But now, what is the output? Output is whether this person is going to pay back the loan or not, or for example, whether the bank can sanction a loan to this person or not. Okay, so if it is yes, you are having yes, no, yes, no, no, yes. Okay, this is an output variable. Agree? Now, who is going to decide that? Who is going to create that output variable? Input variable is fine, but output variable you need to create at least for few persons. Okay, so based upon his past history or based upon his previous loans, right, based upon his EMI paying frequency, whether he did not miss any loans in the past, or based upon his CIBIL score, etc., or based upon lot of these factors, you will create this variable. You will say yes, you will say no, you will say no, you will create this. Like that, you will do it for 1000 members. Fine. Once you do that, okay, then you have the data set ready for your supervised machine learning. Then you can train your model on this data. Fine. And then you can use it for predictions. Okay, that is regarding the supervised. Okay, but here, as you can understand, that creating this output variable is sometimes difficult. Okay, it is sometimes difficult. Okay, and sometimes it is not possible. Okay, or even if it is possible, sometimes it might be costly and require much manual work. Okay, require much manual work. Fine. So due to these different reasons, okay, output variable may not be always available. Okay, because as of now, which the data sets which you are working, these are called as toy data sets. That means what? Sample data sets. Okay, whether we see the iris data set, okay, the flower Setosa virginica vesica, okay, or the tips data set, okay, or the house price prediction data set. Okay, so all these are toy data sets. Okay, so there someone have already created the output variable, okay, and given you. But in real life projects, okay, so no one is going to create the output variable and give you. Okay, so if it is already ongoing project, obviously the output variable is already created, or there will be separate team. Okay, so who is going to create these variables? Okay, so they will manually check each and every record and they will create this variable at least for few thousands of records. Once you do that, then you will have the dataset ready. Okay, then you can perform the supervised machine learning. Fine. Now coming back, due to these reasons which you have just understood, okay, so the output variable may not be present. In those cases, what we are going to have? You are going to have only features. Fine, you are going to have only features. So now the second case, in the second case, which is unsupervised machine learning. Okay, so here you are going to have only features. Okay, you are going to have only features, and our task is to cluster them. Okay, so this is a new terminology. Okay, so it's called clustering. Okay, so our task is to cluster them, which means group them. Okay, group them into different groups. Okay, that's the only thing we can do, because you don't have output variable, so obviously you cannot do prediction. So but you have just input variable. You have like x1, x2, x3, x4, for example. Okay, so this is the data you are going to have. Okay, and these are the input columns. Okay, and like this you are going to have for 1000 numbers. Okay, p1, p2, and you're going to have p1k. Okay, that means 1000 numbers you are having. This data, so when you are having 1000 numbers data, you want to cluster them, guys. Okay, or simply you want to group them into different groups. Okay, into different groups. Okay, let's say I got 3 groups. Okay, so into 3 groups we have done, so that a set of people will fall into each group. Okay, this is called cluster 1, cluster 2, okay, cluster 3. Okay, so how you are going to do that? So the main idea is to group similar people, okay, similar rows, or each row represents a person, right? So similar persons into one group. Okay, for example, in this group, randomly I'm saying like p2 or some 19, okay, some 48 or 32, etc, etc. Okay, certain group of people have fallen into this group. Okay, and
Yes, sir.
yeah, so next, and some other set of people will fall into this, and other set of people will fall into this. Okay, the total 1000 people. Okay, so total 1000 people you have divided into 3 parts. Each part is called one cluster: cluster 1, cluster 2, cluster 3. Fine. So how you are going to do that? Okay, there are different algorithms. Fine. So each category which I'm saying, right, it is at high level, guys. Okay, when I say supervised, okay, so in this you will have the actual machine learning algorithms. Okay, there are different categories. Over here you are going to have. Okay, so what all algorithms you are going to learn in your complete machine learning career? Okay, so as of now, okay, so that will be falling in these categories. Okay, most of them will be in the supervised machine learning. Okay, and few you will see in the unsupervised machine learning, and we are going to speak about what are these. Fine, but over here unsupervised machine learning, as I said, so the task is to group the data. Okay, task is to first group the data. Okay, so once you do that, and this grouping is also called as clustering, guys. Okay, so this grouping is also called as clustering. Fine, so once you cluster the data, and this clustering will be done, okay, based upon the similarity. Okay, and what is the similarity and how you are going to cluster? Okay, so what is the reason why, let's say 19 and 48 are falling in this particular cluster, why not in this? Okay, we are going to see. Okay, so we are going to see different types of clustering techniques, etc, etc. Fine, but the fundamental point of unsupervised machine learning is you need to understand, when I say unsupervised, okay, that means you don't have the output variable. Agree? You don't have the output variable, you have only features. Fine. So, and the task is to do certain clustering. Fine. So and as you can see, the for example, the one of the practical use is the customer segmentation. Okay. So what is a customer customer segmentation? See, I'll give an example. Okay. So in, let's say you're working in a bank. Okay. So and I think usually we receive a lot of calls, right? So like mostly IT professionals will receive most of the calls regarding the credit card. Okay. So regarding the credit card or personal loans or house loans, okay, so they receive a lot of calls on daily basis. Okay. So how do they do that? Okay. So for example, to give a simple example, let's say you have, okay, so let's say you have working in a bank, fine, and you got this data. Okay. So you have, okay, P1, P2, like that. You have 100 people's data you are having. Okay. And you are sitting in a bank. Okay. And the two input features are, okay, so X1, X2. Okay. What is this X1? X1 is income. Okay. What is this X2? X2 is expenditure. Okay. You're having these two details for 100 persons. Fine. So based upon this data, okay, you need to cluster them. You don't have any output variable. Okay. Our task is not for any prediction. Okay. So here we just need to cluster them into different groups. Okay. So that you can, okay, you can provide them the credit card loan calls. Okay. But you don't want to waste your time, okay, calling to a person who has less probability of paying back. Fine. So now usually what happens over here is, okay, these data will be clustered into different clusters. Okay. So let's say this will be divided into 4 groups. Okay. So over here you have, okay, income high, okay, expenditure high. Okay. So income high, expenditure less. Okay. Income less, expenditure high. Okay. Income less, expenditure is also less. Okay. What is expenditure? How much they're spending? Fine. What is income? How much they're earning? Fine. So over here, this data, okay, this data, 100 people's data, this data will be divided into 4 groups. Okay. Each of these will be called a cluster. Okay. This is cluster 1, cluster 2, cluster 3, cluster 4. Okay. However, how we are going to do that, what type of algorithms we are going to use, that we are going to see later. Okay. But as of now, just understand at high level. Okay. What will be the clustering? Okay. Once you do this clustering, then if you see over here, so this particular person, out of this, who is the most profitable person is from for banks, who earns more and spends less. Okay. Over here, this guy's, his income is high and expenditure is less. That means he's saving most of the money. That means he has a more capacity to pay back the loan or any EMIs, okay, that he is offered for. Okay. So this guy will be given the first preference. Agree? So can you tell me who will be the second choice from the bank's point of view?
C1.
C1, earns more, expenditure more.
Right. Okay. So this guy will be the second because he's earning more and he's spending more, but at least he's earning more. Okay, when compared to this guy. And third guy will be
Not use income less, expenditure more.
no, which one? The number C3 or C4?
C4.
Fine.
Yes, yes.
Right. This guy is C4 because he's earning less, but also he's also spending less. That's fine. When compared to this guy is the worst way because he's not earning anything, but he's spending more. Okay. So, but if you ask how he's spending, I'm also not sure how he's spending, but that he's taking, that means his spending percentage is extremely higher than the remaining guys. That means if he's getting, like, for example, 50,000, I think he's spending almost 45,000. Okay, something like that. So this guy is a fourth guy. So all these 100% will be segregated into these 4 categories. Fine. And these details, obviously, they can have very easily, right? So income, definitely they're going to have, because that is those are the guys who have all your bank details, so directly they can see what is your income. Okay, and expenditure, that also they can see, okay, because they have all your transaction details, okay, deposits, withdrawals, everything. Okay, so they will have these two details, and based upon this will be clustered or grouped, okay, into different groups. Once they are done, then most of the calls will be hitting for these guys. Okay, so most of this list will be shared, okay, and this will be given the topmost priority, okay, and most of the calls will be given to this person, okay, and the least number of calls will be given to this person. Agree? So obviously you can see a practical application of a clustering, okay, because if it is not this way, if you directly take 1 to 100, and if you start calling person 1, person 2, person 3, okay, and if most of the calls are going to this person, obviously it's a waste of time. Fine, even if you sanction a loan to this guy, that will be a headache for the bank, because he cannot pay back, okay, because his planning is too bad. Fine. So to avoid that, they do clustering, okay, fine. And once this list is segregated, okay, this guy will be given the most priority next to this guy, okay, like that, next this guy, okay, but mainly they'll focus on this guy whose income is more and also expenditure is not that high. Fine. So that is one thing. And there are different examples of clustering, okay, and as you can see, even in the, okay, so clustering, so as I said, these two are very, very important categories of ML, guys. Okay, so as of in our course also, we are going to study about these two. Okay, we are going to see what are these, okay, but these two are very important. Okay, and in unsupervised also, okay, so many, as I said, this one customer segmentation, right? So bank is only one simple example, okay, but all of us, okay, you, me, everyone are actually segregated into different categories from different companies. Okay, for if you take Amazon, okay, so Amazon, what it does, okay, it will segregate uh, every user, okay, who visits into different categories, like based upon his previous purchases, okay, based upon his wish list, okay, or based upon his personal data, okay, it will segregate. Okay, so what is the age of this person and what type of this person is, okay, or whether he's a kid, okay, whether he's an adult, or whether he's a frequent buyer, or whether he is a occasional buyer, okay, whether he is a seasonal buyer, that means only when there are discounts, whether he's going to buy. Okay, so like that, they will segregate every person into different baskets. Okay, so based upon that, okay, so you will be given certain offers, okay, because the offers which I get are different from the offers which you people get. Fine. So like that, okay, and even the other companies like Netflix, all these OTT platforms also, they keep on segregating customers. Okay, these persons watch uh genres, okay, genres of the movies. Okay, so when I say customer segmentation, so it is at a very broad level, guys. Okay, so every company you take, okay, they will segregate their users, okay, into different categories, okay, so that they can do focused, okay, I would say they can provide some focused content, okay, instead of generalized content. Fine. So even in the Netflix also, so they will segregate the people, okay, that's why. So based upon your previous, okay, watch history, you will get certain suggestions, okay, so because people who watch this also watch this, okay, fine. So that means they have already segregated the people, okay, into certain categories. Okay, so then if you're also watching uh some one of these, okay, they will also tell you to watch this. Okay, so this is not exact customer segmentation example. Okay, so this comes under a bit of recommendation which you're going to see in a while. Okay, but the first level of this will be segregation of customers. Okay, so I would say those are the applications examples which we can think of regarding the customer segmentation. Okay, so where you are creating clusters of the input data. Okay, fine. So once that is done, okay, so is unsupervised clear, guys?
Yes, sir, clear.
Yes, sir.
Okay, so next thing is semi-supervised, guys. Okay, semi-supervised. Fine. Now, what is this semi-supervised? Now, coming to, let's try to understand this. We understood supervised. We have both features and target. Agree? We have seen unsupervised. You are having only features. Next, now what is semi-supervised? Okay, now over here what happens is, okay, so it's a combination of these two. Okay, that means over here what happens when you initially got the data. Okay, when you initially got the data, you don't have, it is kind of unsupervised. That means you don't have any output variable. Okay, you don't have any output variable. Okay, you just have the data. Okay, so from that you first do clustering. Okay, so you first do clustering and create different clusters. Okay, and then you label each of the cluster so that the output variable is getting created. Once the output variable is getting created, then this becomes supervised ML. Okay, I'll repeat. See, initially in some semi-supervised, you don't have any output variable. Okay, you will have just raw data, that is only features. Fine. Based upon that features, when you have only features, what is our task is going to be? It's going to be clustering. Fine. So you are going to cluster the given data into different clusters. Once we have different clusters, you are going to label each of the cluster. When I say label, okay, that means you are creating the output variable. Okay, so once you create the output variable or the target variable, fine, then you have both input and output. Okay, you have both input and output. Fine, and then now you can apply supervised machine learning over there. Okay, so that's why it is not direct supervised, because you don't have direct output variable. Okay, when you got the data, you not have the output variable, you have created those, so that's why it's called semi-supervised. Okay, so finally it's going to become supervised, but it's not direct complete supervised. Okay, it's a semi-supervised. Fine. So, and also just one thing to mention to you guys. Okay, whenever I'm using any terminology, right? So if you're not getting it, just ask me. Okay, because for me these are all very common. Okay, but for you it might be new, right? So because I just use label. Okay, I don't think I've already told you what is label. Okay, now label is also target variable. Okay, so like that, when I use any new terminology which you did not which you are hearing for the first time, okay, you just raise your hand and let me know. Okay, so the output variable is also called as output, or this y is also called as output or target, or also called as label. Okay, so also called as label. Okay, so the different names. Okay, fine. Now coming back, see, in semi-supervised, what happens if you take the previous example itself? Okay, so over here, now when you got the data, you don't have any output variable, so that's why what you did, you have done the clustering. Okay, so once you've done the clustering 1 2 3 4, now you can label these categories. Okay, you can label these categories. Okay, so what I'm doing, I'm labeling, I'm saying this guy as a any label you can give. For example, I will say this is a, I'm saying priority 1 P1. Okay, this guy is a priority 2. Okay, simple priority 3. Okay, priority 4. Okay, so now earlier you were having only income and expenditure. Okay, along with that, we are going to have one more column called as target variable. Okay, target variable. Okay, so in this target variable, okay, for example, I will write here. So what happened for P1? Okay, you are having is income. Okay, I1 you're having is expenditure. This was the original input data, but along with that, since this P1, let's say if is falling into P3, okay, this category, okay, again you will confuse with P1 and P2, right? So let me call this as input, guys. Okay, so let me call these are the inputs. Okay, input will be denoted with what? X1, right? X1, X2, X3, like that you are having X100. Okay, so now over here you are having, okay, X1. So X1 is the input. Fine. So for the X1 record, you are having I1 is a income. Okay, E1 is his expenditure. Okay, now X1 is a first input. So, and this person is falling into, let's say, third category. Okay, P3. So the output variable for this guy will be P3. Okay, next X2, second person, I2. Okay, E2. Okay, let's say he's falling into first category, P1. Okay, like that, you will have X100, I100, E100, and some other category. Okay, let's say some P4. Fine. So now what happened? You have created the output variable. Agree? Earlier you have only this data, income and expenditure. Now you have created this. Now this two becomes X. Okay, these two becomes what? These are my X. That means input or features. Okay. Now what is this becomes? This is my target. The moment you have both features and target, you can obviously convert this into a supervised machine learning problem. Getting?
Yes, sir.
Fine. So the idea here is what? Idea is these don't come along with labels. The labels will be created in midway. Once that is created, then you can convert this into supervised machine learning problem. Okay. Fine. So that's regard supervised, but this, okay. So from my practical experience, I have, yes, we have in one of the project we have used this. Okay. Because that was related to it, textual data. Okay, where you are working on text. Fine. So initially we don't have the corresponding labels for it. Okay, so that means what, whether this, okay, it was related to fine incident sort of thing. Okay, so we just got the raw input. Okay, raw input. Okay, and for each record, so there was a separate team. As I said, creating the output variables is bit costly, guys. Okay, it requires much effort. Fine. So there will be separate team. Okay, so who they usually call as HIL team. That means human in loop. Okay, they're called human in loop. Okay, so there will be separate team in some of the companies. Okay, so the data will be sent to them. Okay, they will check this and they will create the output variable. Okay, based upon certain instructions given to them. Okay, so like that, the output variables are created for all the input data. Once that is done, then this will be proceeded for supervised machine learning. Okay, so what type of algorithm we can use on this? Fine. Okay, so that's about the semi-supervised. Okay, kind of the text classification which I was just mentioning, right? So it's a kind of similar example which I was working upon. Okay, but is the idea of semi-supervised clear, guys?
Yes, sir.
Okay. Next thing, the last thing which we have what is called reinforcement learning. Okay, so reinforcement learning. Okay, so this is actually a separate category of ML, obviously, but which we don't usually see it in like regular projects. Okay, so this is a little advanced. Okay, so what happens over here is, in simple words, if I say in reinforced learning, it works on action reward concept base. Okay, it works on action, okay, reward concept. That means what? So initially this model is trained. Okay, so and once you do the, okay, a certain action is performed by this what we say model. Okay, and once it is done, okay, once it is, let's say once it is performing as per the expectations, okay, this model is given certain rewards. Okay, and if at all it is not performing as per the expectations, fine, so it will be not given any rewards. Okay, and it's and the goal is to gain as many rewards as possible. Okay, it will be trained in such a way, okay, so that every time it does a mistake, okay, every time it does a mistake, fine, so it will the rewards will be reduced, so that the system slowly understands that it should earn more and more rewards, so that it will try to rectify its mistakes, and slowly it will increase its performance higher and higher. Okay, so as I said, this is a very simple definition of reinforcement, and generally people don't use this or don't work on this. I have not personally worked on this. Okay, and most of the projects which we deal upon in our companies on daily basis, okay, so majority of the projects will not be including any reinforcement learning. Okay, because this is very bit advanced as of now. Okay, so as you can see, one of the example over here is driverless cars. Okay, so because what happens is in driverless cars, okay, so when he's driving, so obviously he should be trained in such a way that it should drive only on particular one way. Okay, he should not cross lanes. Agree? And he should not hit any object, and he should stop at the what at the traffic signal, etc., etc. There will be hundreds of instructions. Okay, so how it's going to learn? Okay, so each time it does something wrong, okay, its rewards will be reduced. Okay, so the model inside that, okay, and then every time it does something correct as per the expectations, it will be given more rewards. Okay, so like that, it will slowly understand. Okay, it's called action reward. Okay, so but if I okay, so if I just okay, see, as you can see, the reinforcement learning, it's called as well learning from mistakes. Okay, and one of the best example is chess, guys. Okay, so you remember chess? Okay, so in our childhood also we used to play chess. Okay, with the system. And how does it learn chess? Okay, so earlier, first of all, it will once it is first basic instructions will be given, like how does each and every chess coin can be moved. Okay, let's say the pawn we can move only one step and the elephant can move only in the straight direction, like that. Okay, basic instructions will be given. And once it starts playing, okay, based upon its move, okay, the rewards will be given. Okay, if it is done a excellent move, rewards will be given, and if it is done a stupid move, rewards will be reduced. Like that, it will slowly understand whether the previous move is good or bad. Okay, or whether it is the expected move or not. Okay, so like that, slowly it will understand, okay, what needs to be done or what should not be done. Okay, and then over a period of time, it will be trained. And as you can see, the chess, as of now, the chess, I mean, the computer chess game can defeat almost any person, or even the toppers. Okay, I would say, what do we call them? So even the first rankers in the chess champions also, it is able to. Sorry, Karthik.
No, Santosh.
Yeah. So, and also there was a very famous example of reinforcement learning. Okay, it's called AlphaGo. There is a so as you can see, they'll use in the robotics. Okay, so everywhere it need to learn. Okay, and from its own mistakes, right? So it will be so called as AlphaGo. Okay, AlphaGo is able to learn the Go from scratch. Okay, so it's a game actually. AlphaGo was a game. Okay, so Super Mario and AlphaGo. Okay, so what happened? So once they have trained this AlphaGo, okay, once it has trained, okay, as you can see, Google DeepMind. Okay, can you see this Google DeepMind? Okay, Google DeepMind is it's a part of this DeepMind. Okay, in Google, you have a separate, okay, a team, okay, department called as DeepMind. Okay, so who mainly works on AI. Okay, so AI, etc., and all the advancements. Okay, so which we see, okay, from Google will come from this team. Okay, and the research team will be present over here. And one of the famous, we call him as the father of the data science. Okay, I think his name is Jeffrey. Okay, father of data science, his name is okay, he's recently moved to okay, Jeffrey, sorry, I forgot his name. Jeffrey Hinton or yes, this is Jeffrey. Okay, Geoffrey. Okay, so Geoffrey. Hmm. Yeah, so this person who is also called as, okay, let me just show you. Okay, godfather of deep learning. Okay, so along with Jan LeCun and Xiao Bengio. Okay, these persons are called as godfathers of deep learning. Okay, what are the advancements which you see, guys? Okay, in the deep from the deep learning only. Okay, so I'll also give you what is a basic. what does deep learning mean, okay, in some other time, okay, but what the actual advancement which you see, okay, so either if you are able to speak with your TV, okay, either, the way how we do, we'll say hi Alexa, etc., okay, whether you do that, whether you are able to, okay, whether people are able to drive Tesla driverless cars, okay, so or actually many numerous examples, okay, so all these are coming from deep learning, okay. There is a separate category called as deep learning, okay. So as I said, you have ML, which is machine learning, which we are going to study, and next you have called as deep learning, and also next you have called as NLP, which is natural language processing, okay. Actually the most of the research happens in deep learning, okay, and the applications will be present in the NLP, okay. So these advancements, okay, most of the advancements what we have are coming from certain team, okay. So and the most three fundamental pillars are three persons, okay. One is Jeffrey Hinton and Hoshua Benju and Jan LeCun, okay. And the reason why we are studying data science, okay, few people, okay, are these guys are the responsible. And also, yeah, so if you see, there's a team called as Google Brain, okay. So Google Brain was a deep learning artificial intelligence research team, okay. So I think under this stream only we have DeepMind, okay, or I don't know what is a threat hierarchy, okay, but we have Google Brain and DeepMind, okay. So different teams, okay, who work on artificial intelligence, okay, and the research, etc., okay. So over there, okay, coming back over there, okay, so once they have trained this reinforcement learning model, okay, on this AlphaGo, okay, so it has defeated the world champion, okay. It has defeated the world champion in a row, like 3 times, okay, 3 times in a row. So then actually it came into picture, okay. So because of this game, okay, so it became famous. And because you can go through what does this game is, okay. It's not that easy game, okay. So that's what I have seen, okay. I also did not okay like see what exactly this game is, okay. But the point over here is it is not that easy game, okay. That's the reason once after, see, they have trained it for 40 days, okay. So it has able to train it on for once it has trained, okay, they trained for 40 days. AlphaGo 0 was able to outperform the version of AlphaGo, okay, known as master that has defeated world number 1 KG, okay. See, this is a person KG, okay, so who was the world champion at that time, okay. And they have, so they have trained, I think they have trained first initially AlphaGo, okay. So AlphaGo was game, and once they have done this, it is able to outperform the person, and it has defeated the world champion, fine. So that is the example of reinforcement, okay. So as I said, it works on the action reward system, and which we don't practically use, okay, fine. So coming to that, and also we also have another type of ML, so which comes under recommendation system, guys, okay. So which is a recommendations system, okay. So over here, what does it happen? This is also not a very regular type of ML, okay, but I would like to just give you a basic idea. Over here we will basically have task is to create some recommendations, okay. So one simple example should be Amazon, okay. So in Amazon works on mostly recommendations, okay. So you open anything, you search for any item, okay, so you will have hundreds of tens of recommendations, fine. And also once you buy this, okay, once you scroll down, you will see frequently bought together, fine. So you will have the item which you have plus some other item you will have, agree. Or you'll also see people bought this, also bought this, okay. The earlier I was saying, right, so that comes under actual recommendation system, okay. So it's continuously recommending something. How it is going to recommend, okay. So it will, as I said, it will analyze, okay, based on the cookies. So you say you will accept cookies, right. So from that it will extract your data, okay. So from that you will try to understand what type of person you are, what kind of personality you are having, okay. So like that, from tons of data, right. Amazon, how many people uses Amazon, okay. I would say some billions of people, okay. On as of today, some billions of people will uses Amazon on daily basis, right. So on this data, so obviously they will have lots of data, and they will segregate. Okay, they will segregate these into different groups, and then they will start analyzing or grouping people into different categories. Okay, as we have seen. Okay, they will use some advanced clustering techniques, and then it is easy for them. Okay, a person like me, if I select an item, so then they will check across all the data that is available, and they will say what is the majority of the people who bought this item also buying this item. Okay, fine. So for example, if I'm buying a broomstick, okay, if I'm buying a broomstick, it will suggest, okay, people who are buying broomstick is also buying dustbin. Okay, something like that. Fine. So have you seen this example in Amazon? Whenever you are scrolling through the website, have you seen that people who bought this also bought this? Anyone has seen?
Yeah, Santosh.
Okay, fine. So that will be regarding the recommendation system. Okay, so then what is major difference between unsupervised and recommendations? Okay, yeah, see Srisha, good question. Unsupervised. Okay, so before that, I'll answer your question now. Okay, earlier what did you ask? Only prediction done in supervised learning, not in other types. No. So now to answer that question, predictions will be done in both supervised and also semi-supervised. Okay, but the difference is in supervised directly you can proceed for the predictions, but in semi-supervised you need to first create the labels. Okay, is it clear? The first question, Sirisha?
Yes, sir.
Okay. Now your second question is then what is major difference between unsupervised and recommendation? See, in unsupervised you're doing only clustering. Okay, so over here in unsupervised you will just cluster the data. Okay, that's there in your job. Okay, either 3 clusters, 4 clusters, any number of clusters as per the data you're going to cluster. Fine, that's all. But coming to recommendations, your job is not to cluster. So here you are going to recommend. Okay, whether you use cluster, as I said, one example is clustering. Okay, but there may be other techniques what they might be using in the backend. Okay, but the idea is not about the clustering. The idea is to recommend. Okay, so idea is to analyze. Okay, different types of people and recommend. Okay, items based upon their matching. Okay, so that means what does majority of the people are buying? Okay, once they buy this, next this set of people what they are looking for. Okay, if they're like 1 lakh people who have bought this item, and from this, if let's say some 80 lakh people are checking for some other item, so obviously these two are getting bought more frequently, right? So that's how they recommend this item along with this item. Okay, but the idea is to recommend something. Okay, or this also works in what? Same thing, as I said, this also works in your Netflix also. Okay, you will have lots of recommendations. So how it's going to recommend? Okay, the people who have watched mostly let's say this particular horror movie, okay, so is also watching this horror movie. Okay, this is because their mindset is similar. Okay, their personality is somewhat matching. Okay, so even in horror movies also there are different types of horror movies. Okay, so one will be, let's say one horror movie will be full of blood and gore. Okay, one will be just based upon the psychology of the horror movie. Okay, so like that. Okay, the people who have watched horror movies, I don't think they will be watching some family dramas. Okay, so because their personality will be different, right? So based upon this, based upon your past history, it will give you the recommendations. Okay, so here the idea is to recommend. Is it clear, Sirisha? Okay, so that's about the overview, guys. Okay, so now just to before we leave, so as I said, these two, okay, or you can also say these 3, okay, but fundamentally these 2 are the extremely important machine learning categories, okay, which we are going to see in our course, and we are going to see all the famous available algorithms in this both. Okay, inside this you also have further segregations in supervised. Okay, that means you will have classification, also regression. Okay, but what are those we are going to see in our next class, tomorrow's class. Okay, so based upon that, okay, in this classification we have different algorithms, regression you have different algorithms, and it's unsupervised, which is also called as clustering, you have different algorithms. Okay, so altogether we have I would say 10 algorithms. Okay, so these 10 algorithms are the most important algorithms for the beginner. Okay, and not only beginner, so those are the most famous 10 algorithms out there. Okay, so any person using any ML algorithm in their project, so will be one of these algorithms. Okay, fine. So any doubts, guys? Are you able to
No.
understand?
Yes, sir.
Okay, fine. So fine, guys. In tomorrow's class, okay, we will start with supervised. Okay, don't worry. I'll again give you different examples of supervised and unsupervised. Okay, so from tomorrow we are going to see in depth what is supervised, and then we'll start with different algorithms. Okay, so before that, I'll also tell you like what are the for example, I'll tomorrow's class we are going to see how you can what are the different types of ML models. Okay, so in the sense not into the actual algorithms, okay, but how in different ways, how are the different ways which you can train the ML models, and also what are the major challenges you face in ML. Okay, so we are going to see few general concepts, okay, before we enter into the actual concepts. Okay, so because these concepts needs to be discussed now, okay, because we can't discuss it once we enter into the actual ML. Okay, so we will see few related concepts regarding the ML, okay, and what are the different ways of training, challenges, okay, advantages, etc. Okay, once that is done, we are going to deep dive into each of this category. Okay, we are going to see in depth what is ML, supervised ML, and what is classification, examples, regression, lot of things. Okay, fine, guys. Okay, I hope that's all from my end. Fine, I hope it's clear. Sir, I'm interested in the stock market investment. Can you suggest any videos? Is this our class help for it? Okay. No, what are you saying? You invest in the stock market investment. How is the stock market investment related to our topic, Sirisha? No, are you saying stock market prediction? Okay, fine. So we are going to see. Okay, see for stock market prediction, right? So for the exact stock market, you need to see something called as time series. Okay, you have time series analysis. Okay, why? Because in the stock market, what happens? The prices changes dynamically. That means it changes almost on hourly basis or minutes basis. Fine. So if the base this simple algorithm which you can use is supervised machine learning algorithms. Okay, so some regression, and specifically regression. Okay, so or to be very specific, you need to go for the time series analysis. Okay, fine. So we'll see when we reach over there. Okay, but if you want some suggestions, definitely I will send you some videos. You can check that, check those. Okay, fine. Any more questions? Okay, guys. Okay, thanks for joining. Let's meet tomorrow same time.